We're covering Chapter 1's Sections 7 and 8 today. Okay, so Section 7 covers exponents, square roots, the order of operations, and then algebraic expressions. Okay, so exponents. Exponents represent repeated multiplication. Basically, mathematicians are lazy. So they do not want to write down, if they want to write, 3 times 3 times 3 times 3 times 5 times, they don't want to write all that down. So they came up with notation called an exponent. So the exponent is the little number on top, and the number on the bottom is called the base. Okay? So what this means is if I have 3 to the 5th, that's how you read that, 3 to the 5th, that means I'm taking 3 and I'm multiplying it by itself 5 times. That's what that means. And if I do this, this is 9, and that's 27, and that's 81, and that's 243. Exponents get large quickly. So just to know, though, the important thing to understand right now is that this means how many times you multiply this number by itself. Evaluating. All right, so for A, 6 squared, I need how many 6s? 2. So that's 6 times 6, so that's 36. Okay, 5 to the 3rd, 3 5s. So 5 times 5 is 25, times 5 is 125. So you can see they get big fast. I'm just multiplying 3 numbers, I'm already up to 125. They get very large very fast. And then C, 2 to the 4th, is 2 times 2 times 2 times 2. So that's 2 times 2 is 4, times 2 is 8, times 2 is 16. Yeah. I'm going to write some things and you can write what I write. Okay, so powers of 10. I would write that, powers of 10. Oops. It's highlighted. That highlighter sucks. Okay, powers of 10. All right, so if I have 10 to the 1, that's 10. 10 squared is 100, because it's 10 times 10, so that gives me 2 zeros. Exponent is 2, I have 2 zeros. 10 to the 3rd, 3 zeros. 10 to the 4th, 4 zeros. 10 to the 9th, 9 zeros. Powers of 10 are very nice because you don't actually have to multiply anything. You just add zeros. And the number of zeros is the same as the exponent. Okay, so exponent equals the number of zeros. All this down. But square roots, so we have square roots, which look like that, and the exponent 2 are reverse of each other. Okay, and that's called an inverse operation. Inverse has an S. And what that means is they undo each other. So addition and subtraction undo each other. Their inverse operations, multiplication and division, undo each other. Well, square roots and exponents of 2, so squares, these are squares, undo one another. The squares, finding the square roots are a little bit easier. So I look at the square root of 9. I'm going to pop back for a second. 3 squared equals 9, right? So if 3 squared equals 9, square roots undo squares. So I'm just going to write that right there. 3 squared equals 9. So the square root of 9 equals 3. Now, technically speaking, it can be positive 3 or a negative 3, but we're going to use the primary, which is the positive right now, okay? So for right now, we'll just use positives. 64. 8 squared is 64. So the square root of 64 is 8. Okay. 1 squared is 1. Okay, I'll slow down. Okay, so since 1 squared is 1, the square root of 1 is 1. And I didn't actually put this on your list, but what do you guys think the square root of 0 is? 0. Okay. And again, when we're using the positives, right now those are known as the primary square root is the positive 1. There's also a negative 1 because it can be positive 8 or negative 8, but right now we're just going to use the positives. Just for right now, if I say a negative number, there's not going to be a solution because it's undefined. Okay, so at this level of math, right now you guys are not able to take the square root of a negative number. In the future you will be able to, but for right now, if it's a negative under the square root, your answer is going to be that either no solution or undefined. Order of operations. There's a purpose for this, okay? The order of operations tells me what order to do stuff. So I'm going to say what order to do math stuff. Okay, and the reason we have an order of operations is so that if I give you a math problem and some teacher in India and another teacher in China and somebody in Australia and somebody in South Africa and somebody over in Egypt and maybe down in South America somewhere, we all give students the same problem, you should all come up with the exact same answer. So this is, did anybody learn PEMDAS? Or maybe you learned, please excuse my dear Aunt Sally. And those are nice because they let you know an order. But they're not great because what happens is they make multiplication seem bigger than division, and that's not necessarily the case. And they make addition seem more important than subtraction, and that's not necessarily the case. And then P for parentheses, well, it's not just parentheses. So I like to write it like this. And I'm going to actually move that E a little bit further from that P. Sorry. Okay. Now, I also think of it as a royal court. The P is the king. He has the most power. And it's not just parentheses, although that's how you learn it. It's also brackets, braces, absolute value bars, and fraction bars. Okay, and so parentheses we're familiar with, those look like that. And brackets are the square parentheses. And braces are the weird pointy parentheses. Absolute value bars are two straight lines that go up and down. And then fraction bars, you have, let's stuff on the top and stuff on the bottom. Okay, and those are all considered the same value. Those are all grouping symbols, so that's a terrible straight line. This is me cheating. Sorry, you guys can't do this. Okay. So what we have is all grouping symbols. So all grouping symbols are king. What is king? Right? They're just kings of different countries maybe. But they're all kings. They all come first. They're the most important thing in the problem. Then the next thing you get is the E, that's exponents. But it's not just exponents. It's also square roots. And other roots, cube roots, fourth roots, and things like that, but we're not really there yet. So for right now, all you'll be dealing with is square roots. So it's both exponents and square roots have the same value. And if parentheses are the king, exponents are the queen. Oh, no, not red. Okay, so when you're in the royal court, the king has the most power. You deal with him first, right? But if the king's not present, you go to the queen next, because the queen has the second most power. So if the exponents are the queen, next we have multiplication and division. Only it's not and. The way you learn it in elementary school or earlier or later, it made it seem like you go through the problem, you do all the multiplication, and then you go through the problem and you do all the division. But that's not actually the case. You want to do one or the other. So you do multiplication. Multiplication has a C in it. Or division. And you do those in order as they appear. And that's moving the same direction we read. So left to right. Multiplication and division have the same power. So if, while you're working your problem, multiplication comes first, as you go across, you do multiplication first. But if, as you're working your problem, division comes first as you move across, you're going to do division first, because multiplication and division, that's the prince and the princess, right? Prince and princess have the same power. We're going to pretend there's no difference between the sexes. Okay. So, prince and princess have the same power. And then you have addition and subtraction. Those are the peasants in our royal court of math. And peasants, of course, have all the same power, right? All the peasants have the same power. They're peasants. They've got no power. So addition and subtraction are like multiplication and division. They have the same power, so you do them in the order that you see them. Okay. We have subtraction, division, addition, so we're going to do the division first. So that's going to be 15 minus 5 plus 3. Okay. Everything else just gets written down exactly the way it was. And then 15 minus 5 is 10 plus 3. And then 10 plus 3 is 13. Okay, and then 3 times 7 is 21 minus 1, and then 21 minus 1 is 20. Okay. Now here's something interesting, because remember how I said square roots and exponents have the same weight, except this square root's not just acting like a square root. It's also acting like a grouping symbol. So I want to come back and add it to our list and put, I didn't mean to do it, I meant to do a comma, roots. Okay, so roots can act as a grouping symbol as well. Okay, so it's grouping this 64 and the 36 together, so I need to do that first, because it's do you guys see how it's grouping them together? So I'm going to do 64 plus 36 is 100. Okay. And now I can either do this in 2 steps or do it in 1. I can either take the square root and take 2 to the 3rd at the same time, or I can do them separately, because they have the same weight, so I can do them at the same time. But I'm going to do them separately just for right now, because we're getting used to this. So the square root of 100 is 10 minus 2 to the 3rd. Okay, and 2 to the 3rd, let's just put it up here, is 2 times 2 times 2, so that's 8. And then 10 minus 8 is 2. Okay. Now, what I don't want to see happen, this is a perfect square and this is a perfect square. And some people might take the perfect square of this one and then take the perfect square of that one and then add them together, and that is not the correct answer. Because if you do that, you get 8 plus 6 and then you get the square root of 14. Or sorry, 8 plus 6, so you get 14 instead of 10. You need to add them together first, or do any subtraction or multiplying or anything underneath the square root first, and then take the square root of it. Okay. A lot going on. But we're going to start at the inside. So we're going to start here. And then we're going to work our way out. So what happens is we're going to add, oops, wrong pen. We're going to add 5 and 2. 5 plus 2, that is not so bad. That's 7, right? Then everything else, I'm going to keep exactly the way it is. I'm just copying it exactly the way it was. Not doing anything to it, I'm just copying it. Now I look and I'm inside brackets. Those are the next inside parentheses. So inside these brackets, I have addition and an exponent. So I need to do the exponent first. So that's 49. And again, I'm going to write everything else exactly the way it was. Okay. So again, I'm doing one step at a time, very little small pieces so that I can keep track of it and it doesn't get confusing. I'm still inside this bracket. I didn't finish, I just did the one exponent. So next I'm going to add 4 and 49, which is 53. And everything else I'm rewriting exactly the way it was. Okay. Now this right here, this 4 next to this bracket with nothing in between them, that symbolizes multiply. Okay, so if you see that like this, that tells me to multiply if there's nothing in between. So this is telling me negative 4 times 53. I'm inside these braces now. And inside these braces, the first thing I need to do, I have subtraction, multiplication, and addition. So the first thing I need to do is that multiplication. Okay, and I have not memorized my 53s. So I'm going to rewrite everything else exactly the way it was. Okay. Again, I'm still working inside these braces. Oops. So I'm going to do subtraction first, because that's the order it comes in. So 300 minus 212 is 88. You notice this poor minus 31 has just been hanging out this whole time. This plus 8 has just been hanging out this whole time. Just hanging out. I'm still in the braces, so I'm going to do 88 plus 8. It's going to give me 96 minus 31. And finally, I'm almost done. 96 minus 31 is 65. So you're going to plug in given values for the variables and then use your order of operations. Okay, so when you see that word evaluate, that's what that means. In algebra, you'll see evaluate, simplify, and solve. Okay, evaluate, you're going to plug in the variables, the values for the variables, and then you're going to use your order of operations to simplify. Okay, and simplify means to reduce to lowest terms. Okay, so 2 plus 5 is not simplified. But if I add them together and I make it one number 7, it's reduced to its lowest terms. It's just one term. That's simplified. So that's what simplify means. So evaluate is to plug things in and determine what value it has after you've plugged in. And simplify is to reduce it to its lowest terms. And then solve is what happens when we don't know what the x equals and we find it. We're not there quite yet. So what I do, if I have 5a plus b, a equals 6 and b equals 10. I'm literally going to replace, now 5a, this is 5 times a. Okay, if there's a number and a letter and they're just stuck together, that's multiplication. So this becomes 5 times 6. Plus b, well, b is 10. So I replaced the a with the 6 and I replaced the b with the 10 because that's what they equal. It's like if you ask me for change for $1. As long as I give you some manner of coins that equal $1, you probably don't care if it's dimes and quarters or nickels, or as long as it's probably not pennies because you probably want it for the vending machine, but as long as I give you $1, they're the same value. So it doesn't really matter which you have, it's $1 or 4 quarters. That's the same thing here. A and 6 are the same thing, so I can exchange them. Then I do my order of operations. Multiplication comes first. So we have evaluated this expression is equal to 40 or worth 40 when a is 6 and b is 10. But you'll notice I have not used any equal signs. And the reason I haven't used any equal signs is because we typically only use equal signs when we're solving actual equations. Right now I'm just simplifying, so it's best not to use them so that it doesn't get more confusing later. If you do use them, I'm not going to mark you wrong. It's best not to, but it won't be wrong if you do. I'm going to plug in, okay, x is 12, y is 9, Z is 4. What, question? You sure?
Yeah.
Okay. So X was 12, Y was 9, Z was 4, so I plugged those numbers in. And so I'm going to do what's inside the parentheses first. So 12 minus 9 is 3 plus 4. Right? And then 3 plus 4 is 7. And 7 squared is 49.